So this lecture is the lecture about, we'll start plate tectonics and the different types of tectonic plate boundaries. We'll just talk about one type of tectonic plate boundary this lecture, and then the next one I'll save the other two types of plate boundaries. So just as a general introduction, we're going to talk about tectonic plates. Plate tectonics is the idea that Earth's surface is broken into all of these pieces that move relative to each other. So sometimes plates are moving towards each other. Sometimes they're moving away from each other, and other times they're just sliding past each other. So there's three different types of motion that occur in tectonic plates. So you should have seen some similarities between the four maps that you were finishing up for the last lecture quiz, where you had the map of the age of the ocean floor, you had the map of the earthquakes on the right side here, volcanoes on the bottom left, and then topography, how high something is above sea level on the right side. So what you should have noticed is that basically anywhere where the ocean floor is young, you get lots of earthquakes that occur, you get volcanoes. Anywhere that the ocean is old, you also get earthquakes, you also get volcanoes, and you get very deep ocean. So we're going to talk about those features again that we had mentioned the last time, the trenches and mid-ocean ridges. Those are going to come back up again in the lecture today. So again, Pangaea was the supercontinent that was together, and then it drifted apart, and we just have our timeline playing, showing us the different tectonic plates, the boundaries or the borders of those tectonic plates, and then the direction of movement. So we know that continents move over time. We know that they drift over time. So I'll remind you that Alfred Wagner, he died before his work was accepted. So basically it took someone else coming along to finalize his work and to actually prove it and come up with the idea of tectonic plates. And that person was Harry Hess, who was around in the 1960s. So he came up with the idea that it's called a conveyor belt idea, but for every foot of ocean that is generated at a ridge, and we'll talk about the mechanism for that happening here in a minute, for every foot of ocean that you create at a ridge, you destroy 1 foot of ocean at a trench. So it's called a conveyor belt because if you create 1 foot, you destroy a foot somewhere else. Just as a general idea or overview of what that looks like. So if we have this area here, this is like a mid-ocean ridge. So for every foot of ocean that is created at a mid-ocean ridge, it's destroyed somewhere else at a trench. So once Harry Hess came up with this idea, it was an excellent explanation for how continents can move. So if you have ocean being created somewhere, that ocean is going to get wider, so that corresponds to continents moving away from each other. If you have ocean that's being destroyed at a trench, that's usually where two plates are colliding, and one is getting pushed underneath of the other, then you can close oceans back up in response to that kind of push and pull motion. All right, so again, just to remind you of how these line up, if we're looking at the mid-ocean ridge right here, which is your lighter blue color in the Atlantic Ocean, or it's called the East Pacific Rise if it's in the Pacific Ocean, those tend to correspond with brand new ocean. So that's our red colors here. That could be ocean that's a couple days old, or that could be ocean that's a couple 100,000 years old. That's brand new ocean. All right, so based on this, this kind of gives you an idea of that conveyor belt theory or idea from Harry Hess. So for every foot that's created here at a mid-ocean ridge, so here's the mid-ocean ridge, there's a heat source underneath the mid-ocean ridges that is a source of magma or lava once it spills out onto the ocean floor. And what's happening here is that two tectonic plates are splitting away or splitting apart from each other. More material or magma rises out, spills out onto the ocean floor, and it forms brand new rocks on the ocean floor at a mid-ocean ridge. As you go away from the ridge to the right in this diagram, what you'll notice is that there's a spot where the ocean is going underneath of a continent. So we got a continent with volcanoes here. We have an ocean going underneath of that continent, and we have a trench, which is this feature right here, that kind of deep underwater valley. So for every foot of ocean that you create at a mid-ocean ridge, a foot of ocean is destroyed at a trench. All right, so you should be able to answer questions 1 through 3. Feel free to pause and then come back once you've answered those questions on the quiz. Before we move on, I just want to recap Earth's layers. So when we're talking about plate tectonics, we're mainly just talking about the lithosphere. So the lithosphere is the crust plus the outermost part of the mantle, and then underneath of the lithosphere is the asthenosphere. It behaves like pudding. It is solid, but it can move like a liquid, like peanut butter or pudding. And tectonic plates are the lithosphere, so they kind of just like move up and down or bob up and down on top of the asthenosphere. So let's define plate tectonics. Plate tectonics is defined as the fact that Earth's lithosphere, so that outermost layer that includes the crust and the upper mantle, it's broken into pieces, but those pieces can move relative to each other. So Earth's surface is basically broken into all of these chunks that we call tectonic plates. There's the North American plate, the Eurasian plate, the African plate, the South American plate, and all of those pieces are moving in different directions relative to each other. The edges of tectonic plates, or the boundaries, are defined by ridges and trenches. So we've already talked about those. Ridges are typically where plates are splitting apart. Trenches are where plates are colliding. So again, if we have a map here, the purple is areas of ocean ridges, and then the red is areas of trenches. So based on that, you should be able to answer questions 4 through 8 on the quiz using this map that you have here. Ridges are in red and trenches are in green. So if you're curious how long it takes tectonic plates to move, or what's the speed that tectonic plates move, a very fast rate of plate motion is about 15 centimeters per year, which is about 6 inches per year or so. So in most people, that's about how quickly your hair grows, the speed of your hair growth. And then slow would be about less than half of an inch per year. The map that you have here is basically showing you the length of the arrow is showing you the speed of plate motion. So based on that, you should be able to answer questions 9 and 10 on the quiz. So here's a bad geology joke, but since tectonic plates take a very long time to move in terms of human life scales, a geologist at lunch says they like the tectonic plate, and the waiter says, very good, that will take time to get here. All right. So let's talk about plate boundaries. So there's 3 different types of tectonic plate boundaries. There's divergent, where plates are moving away from each other. There's convergent, where plates are colliding. And then there's transform, where plates are moving past each other. So for the purposes of this lecture, to finish up, we're only going to talk about divergent boundaries, where 2 plates are spreading away from each other. So where do divergent boundaries occur? Anywhere that you have a ridge on Earth is a location where you have 2 plates that are moving away from each other. So you have new ocean being created, or you have new continental land being created. That's your 2 options. So these tend to look like zippers in maps. So every zipper that you see on here is an example of a divergent plate boundary. So in the US, basically our closest one is the Mid-Atlantic Ridge out in the middle of the ocean, middle of the Atlantic Ocean, and then we have the Juan de Fuca Ridge, which is up off the coast of Washington and Oregon. Okay, so if we have a divergent boundary, just to kind of give you an idea of how a divergent boundary behaves, you got 2 tectonic plates. The arrows here indicate that they're moving in opposite directions, so they're splitting apart. And what happens at a divergent boundary is that you get hot material from the mantle, usually magma, that will rise up, spill out onto the ocean floor, and then create an ocean ridge, which again is that feature. If you're walking on the ocean floor, you'd go up and over that ridge. So here's an animation to play through so you can see how this is done. So you have 2 tectonic plates, they're splitting apart. We have this source of warm material that rises upward, and it fills in the crack basically of where rock used to be, but then it's split apart. This kind of shows you the mechanism for a divergent boundary and how as 2 plates split apart, you get magma that comes up from the mantle, spills up, fills in the crack, and then deposits, forms, solidifies, turns to solid on the ocean floor, and then moves away from the center of that ridge over time. All right, so let's look at an example of a location where the mid-Atlantic ridge crosses through a country. So it doesn't always have to be on the ocean. It can cross through a country. And an excellent example of that is Iceland. So if we're looking at Massachusetts here, Iceland is up in the northern Atlantic Ocean, and Iceland is split in two by the mid-Atlantic ridge. So if you look at a map of Iceland here, here's the mid-Atlantic ridge, and it basically just splits the country in half. So what's cool about Iceland is that you can literally stand between two tectonic plates. So there's this national park in Iceland. I went here in 2017, but basically you can stand. It's called Thingvellir National Park, but you can stand in between two tectonic plates. You can stick your arms out. One of your arms would be touching the North American plate, and the other arm would be touching the Eurasian plate. So given that this is a divergent boundary, what's going to happen is that the Eurasian plate is going to keep moving to the east. The North American plate is going to keep moving to the west. And in the future, we're going to have East Iceland and then West Iceland. So basically the country is just splitting apart into two separate countries, or two separate land masses. Here's an example of the mid-Atlantic ridge crossing through Iceland. So the students for scale, the left side here is the North American plate. The right side is the Eurasian plate, and these two are splitting apart and getting farther apart with time. There's other locations in Iceland where you can see it. You can even go diving, scuba diving between tectonic plates in Iceland here. This is called the Silfra Fissure, but basically you can just go in it, dive in it, left side North American plate, right side Eurasian plate. All right, so in order to finish out your quiz, there's a link basically that you're going to access here. So I have it right here on the slide for you, but you can also go to Blackboard, and on the quiz question, it has a link to the website that you need to go to. So what you're going to do is you're going to read a little bit about East Africa and what is happening to East Africa in terms of it being a divergent boundary. We call it a rift system if it's on land. We call it a mid-ocean ridge if it's in the ocean. All right, and then I just have one more visual to kind of summarize everything up here. So if we're looking at ocean spreading, you can basically take a continent, you can erode it, you can split it apart, and it will start to diverge. So we have two tectonic plates, they are moving in opposite directions of each other. We have warm material from the mantle that spills up onto the ocean floor, and as it does so, it creates new material on the ocean floor, and oceans get wider with time if you have a divergent boundary. All right, so let's just put all these features together associated with divergent boundaries. They're called ridges. So we have Mid-Atlantic Ridge would be an example. If you were looking back at those kind of four maps that you had to look at for the last quiz, what you would notice is that there are shallow earthquakes that occur. So all along a divergent boundary, you can get earthquakes that happen. At the same location, the ocean is going to be very young, 0 million years old, because you're creating brand new ocean at a divergent boundary. And then you still get volcanoes, but they're kind of sparse in terms of the way that they line up along the ridge.